Hello again. This is Nick, and this is the part 4, the last part of NeurIPS Recap 2023 Trends in AI. And we've seen so far, we talked about the Best Paper Award, about the evolution of language models, how to create language model from scratch, issues with data, using simulators for generating data. The previous part was about mathematical proofs with LLMs and math reasoning. This one is about LLMs for tabular data. So this is based on the table representation learning workshop. Here are the papers and two invited talks that I'm going to include. Tables are everywhere: spreadsheets, documents, web pages, databases. I don't really need to convince you about the usefulness of tables. Here are the goals of the TRL workshop: motivate tables as the primal modality for representation and generative learning. In the world of databases, can we load the databases into a language model? Discuss novel methods, system application challenges and opportunities, and obviously bring together the community of NLP and databases and ML. So this is the last year's best paper. Is TabBFN, a transformer that solves small tabular classification problems in a second, which inspired a lot of derivative papers on that. So the idea was that let's create as many graphical models as we can, and create a lot of data from them, for predictive or classification tasks, and then go and fine-tune, pre-train a language model. And then, when I have new data, like 1,000 training points where I have the features and the target value, I give them as context, and I give you the features, and I'm asking you about to predict the target value. So you can see on some toy problems, the representation does really well. Look at here, the TabBFN, the separation surface. It's really impressive that the model, learns how to analyze in a second and predict. It was a really impressive work. And this was the, again, I wanted to mention that this was intended to be an AutoML method. It was saying that in 1 second, it would beat any other model, AutoML model, that would take an hour. There was huge speed ups. Of course, there were some limitations on, 1,000 data points in context, 100 features, 10 classes, no missing values, no regression, and the inference time of the set was high. And of course, they improved it now, yet to be announced. I haven't really seen it on their GitHub repo. They also said that they got sidetracked by ChatGPT, and we're going to talk about that. It was some interesting work. So they tried to take a different angle in AutoML with ChatGPT, but eventually they came up with TabBFN 2.0. Please don't tweet yet. I think they will tweet soon. And they address all the limitations that existed before. They made it faster, more scalable. Now you have a 10,000 context window from 100 to 500 features. Now, here's how they got sidetracked. So they created this system called Café, which is a really cool idea. So it's basically a prompt library. But imagine that you're not a data scientist, and you had to hire someone. You would say, well, build me a predictive model, and I don't know, start with these features. I think these are going to be important. And he goes, she goes and they run some tests, and they come with arrows, curves, blah, blah, metrics. And now, they have to decide about like new features, or, what do I do next? And that's what Café is doing, So basically, you give it the code, the pandas code, your Python code, scikit-learn what you did. It says the metric, and I said, well, drop these features, create these new features. I don't know. So it starts giving you iteration. So it's the data scientist on its own, running like on a loop. And you can see over here that they were actually able to perform really well from no feature engineering, 3.5 and 4. They give them a boost, and now they compare it with with other AutoML systems, and they do really well. And they also combine that with TabBFN as their kind of like inference engine. You can see more examples. So the takeaways from Caffe is feature engineering is very important. LLMs can greatly help. Caffe helps expand the scope of AutoML towards automated data science. And it's much more a human-like approach because you see what's happening and you get through the journey. And of course, they say they combines very nicely with TabBFN speed. Now, it was some other experimentation over there, which I also found mind-boggling, which is, let's take the simple problem. Okay, can a language model learn how to do gradient descent? So you take your logistic regression, you start, or you have your weights. So this is your input data, X and Y's, and you have like the weights at time t, and you teach the language model how to do gradient descent, how to go from here to the next iteration of. So basically, the way you do is you run the gradient descent and you fit that as training data. And in the end, what happens is you give a new data set and you ask it to do the gradient descent in the background and come with the final weights. And in the end, yes, so you can start with these 0 weights and you get the final weights. And they ran this surprisingly experiment where they trained different, regression classification problems, put them all together. And when they were giving a new problem, they didn't tell it, try to do it with lasso, with linear regression or whatever. They let it do the gradient descent on its own. And surprisingly, it was picking the right algorithm, or in some cases, it was combining the algorithms. Very fascinating work from MIT, Berkeley, and Salesforce. I found it really interesting, and they have some interesting data. Now there was this other paper where you put in context it's called MotherNet because it doesn't give you the prediction, but it gives you a network, an MLP that will generate the prediction. So it doesn't really predict for the specific data point, but it gives you a network that predicts that. And that's part of the, that's also called the hypernetwork. That it does something similar. You can read more about that. Okay. So, and here's some more conclusions about hyperfast, and how it works. Takeaways on TabBFN. It's growing, and I think it's going to grow more. Now, one of the kind of like not objections, but observations that I have, that I would really like TabBFN to, because it's its own transformer. It doesn't tap upon ZPT. So I don't know if you could do the same things on the GPT architecture, or somehow combine them. Like, people really want to have one thing. Now, there were some other papers. This is of what the version of what I call Kumo AI. It's this work by this company based on PyG by Yuri Leskovitz. I think Yuri Leskovitz is behind the company as well, where they use all these GNNs, where you basically dump a bunch of tables, relational tables, and you say, well, predict tuples in the tables and tell me, things that I don't know about these tables. Here they do it with a transformer architecture. Okay, so it's kind of like a rival technology. It's still a conference paper. We haven't really seen it at the scale of Kumo, but and there was another paper in the same direction over here. And of course, lots of works about text to SQL and what we've learned so far. This is from Emmanuel Trammer's invited talk, where they basically say that you give a query and some customization instructions. So they have this codex DB that the version 1, and then it goes to version 4. they generate a prompt and they generate code. It didn't really work that well in the beginning, but then they give it what they call the query planning, so some instructions about how to do things, and it goes to 22%. Then what they did is that they put a code verification. I wasn't lean. I don't know if it was lean, but it was some assertions, and they tried 10 times. So the problem here is that it was kind of like failing, um, and then they by putting the retries, they went to 80%. And something that I've also tried, you can start putting code samples. You can automatically generate them, and now with one retry you go to 79%. Now data ambiguity straight bugs, how documentation improves GPT's text to SQL. So basically you go and put some ontological information as part of the instructions. You say that BWD means better than win. It happens all the time because there's basically a lot of subtleties in your database that the language model doesn't know, and the more you talk about it, the more it does better. And this is the other thing, is that when you start normalizing SQL and you're putting more information about foreign keys, it does start working better. So all of these papers kind of like go towards the direction of putting more information and ontological data, metadata, if you want, around your schema in order to get more results. Now, in the next section, we're going to talk about the new frontiers in graph learning. That was a workshop, which I think I didn't really see much progress on the topic that they were advertising. But I think it was very interesting because they posed the right questions. And, it would be nice to see more research and more papers next year that they progress. They make progress towards the questions that they were posed. So here's an interesting story. So they basically talk about the new web and the breakthroughs of language models. So you take the internet, or a chunk of the internet, 10 terabytes of text. You throw it on 6,000 GPUs for 12 days, 2 million, I don't know, 1 to the something very big, teraflops, 10 to the something very big. And you basically get a 40 or 140 gigabyte file. Okay, so that's your compression. That's like a lossy compression. But, is that really the right representation? Like, is that all we need, the large language model? So, I mean, they claim that in the end, you need to take that and convert it to a large knowledge graph, which we know that Google and Amazon and all others have been trying for years, long before LLMs were produced. You can go through past presentation that I posted. It's called the 100-year project. Okay, so, and in the end, they think, well, you have to use this graph, but you still need the language model to interact. So they believe that the end goal is not the language model, it's the language model and the knowledge graph. And they say, well, we don't have exactly that. Well, the best thing we can do is not necessarily build the knowledge graph, but do some type of RAG. Okay, so you go back to the facts, you RAG them, you embed them, and you use that. So that's the best we have right now. But we're far away from being able to do that. But I think as a physician, I really like it. I would really like to see more work on that. Now, there was a tutorial and some workshops around what I call LLM application development. This is more for elementary users, introductory course. This is about instruction tuning and instruction following. That was a workshop that was a little bit more advanced. And the other one was a full workshop on self-supervising. You're going to find some really nice practical ideas on how to do that. I consider them as part of the LLM application development. I'm not going through the workshop. I think we're getting towards the end. So that was the last thing, and I would like to wrap up. So where do we go next? Okay, so we basically celebrating the 10-year birthday of I don't know, we call this language model. I don't know how we should like the 10-year birthday of AI. Not really. There was a long work before, but whatever, it was born with Word2Vec, and now we call it LLM. Celebrates its 10-year birthday. We did celebrate the 1-year birthday of ChatGPT, which was announced in the middle of NeurIPS last year. Yet OpenAI wasn't present at NeurIPS, and I'm just going to pose that question: why do we think OpenAI was? I didn't really see them anywhere. Maybe there were some employees attending, but I think it's a question to reflect and think. The research community, they do use a lot of papers using ChatGPT, but clearly they side with open source LLMs. And I can tell you there was a lot of energy and effort, and that kind of like creative stubbornness and real passion to make language models that you can run in an academic lab and you can do research and don't have to depend on credits on GPUs and big huge clusters. The two main challenges: we need more good data. We need cheaper models, and cheaper models can be cheaper hardware, less parameters, more efficient algorithms. I hope that I gave you a good idea, and there are several examples of things that we have been achieved so far. And this question: will AI push math to its limits? I'm very excited about that. It's probably the first time that we see mathematicians pushed to their limits. It's really interesting times. And allow me to use the nerdy way of thanking you for your attention. I just wanted to give credit to the team that this is from a slide from some authors presenting a paper. And for those of you who don't know, this is the mathematical formula for attention. So thank you for your attention. I want to say that this was a 100-hour project for me to do, which I had to do it, during my free time. But I will continue doing it. It's quite painful, but it gives me a lot of joy in the end. Thank you again, and let's see if we're going to be able to do that for ICLR or ICML that are coming up in a few months. Bye-bye.